Okay, so we left off last hour evaluating these expressions. I want to take a look now at how can we work with the expressions themselves and combine the expressions themselves. So the first thing I want to look at is what happens with these variables when we do operations with them when they have powers or exponents on them. We already know that x times x equals what? X squared. Anything times itself is going to be squared. What happens if we have x squared times x again? X to the third. Very good, because x squared, of course, is just x times another x is x to the third. What if we go a step further and have like x to the third times x to the fifth? Okay, so a lot of you know the rule, it's x to the eighth. X to the third is just 3 x's multiplied together. X to the fifth is 5 x's multiplied together. And if we multiply them with each other, we now have 8 x's multiplied together. And the shortcut is, when we multiply exponents with the same base, we can just add the powers. 3 plus 5 equals 8. But that only applies if we have the same base. So if we have y to the 12th times y to the 9th, we're going to get y to the 21. Perfect. 12 plus 9 is 21. How about x to the 15th times z to the 3rd? We're going to get x to the 15th, z to the 3rd, because those are different bases, x and z. We can only add the powers in the exponents if we have the same base. Here we had y and y, so we can add the powers. We can have multiple variables, however. We could have x to the 5th y squared times x to the 3rd y to the 3rd. I can combine the x's with the x's. What's x to the 5th times x to the 3rd? X to the 8th. I'm just adding powers. And then the y's with the y's. Y squared times y to the 3rd. Y to the 5. 2 plus 3 is 5. So it's not that we can't have the same variables. We can only add powers when the exponent has the same base. So when I have both x and x, I can add those powers, the 3 and 5, to get the 8. And with the y and the y, I can add those powers, the 2 and the 3, to get the 5. How about when I'm dividing, like x to the 5th divided by x to the 3rd, what do I get? Yep, you're right. Some of you know the rule, you subtract them. 5 minus 3 is 2. Again, the reason for that, x to the 5th is 5 x's multiplied together. X to the 3rd is 3 x's multiplied together. Now, we haven't done anything with fractions yet. But one of the rules with fractions is you can divide out common factors. So I can divide out an x. I can divide out another x and another x. And the effect is I've subtracted the powers. 5 minus 3, I'm left with 2, or x to the 2nd. Again, only can combine the powers when we have the same base in our exponents. So if I have z to the 15th divided by z to the 9th, what am I going to get? Z to the 6th. Very good. I'm just going to do 15 minus 9 gives me the 6. If I have y to the 18th divided by x to the 5th, I'm going to get y to the 18th over x to the 5th. I cannot simplify that. I can't combine the powers because they do not have the same base. I have y and x instead of the same variable. Just like with multiplication, however, we can have more than one variable. We can only combine the ones that are the same. So we might have x to the 7th, y to the 12th, divided by x squared y. So I can combine the x to the 7th and the x to the 2nd. What am I going to get there? X to the 5th. Good. 7 minus 2 is 5. And I can combine the y to the 12th and the y. Now, what power is on this y? It's a 1. Good. It's not written there, but it's implied. It's assumed that it's a 1. Any number has a power of 1 on it, even though we don't write it. So that becomes y to the 11th. Good. 12 minus 1 is 11. What if we run into something like this? What can we do there? We've got the x's. It becomes x to the 3rd. Good. Yes, 8 minus 5 is 3. Then the y's. It becomes just y. 3 minus 2 is 1. So it's y to the 1, or I can just write just y. What do I do with the z squared? Just leave it. Absolutely nothing. It's just still z squared. No other z's to combine it with. Similar to that, I can run into problems like this with my multiplication. Multiplying x to the 8th y squared times x to the 9th z to the 5th. What can I combine here? The x's. X to the 8th and x to the 9th make x to the 17th. I'm multiplying now, so I'm back to adding powers. The y's and the z's, there's nothing to combine with each of those. So I'm just going to do y squared z to the 5th. Question always comes up. How do I know that I should put the y first? It really doesn't matter. But in mathematics, there is mathematical grammar, is to always put them in alphabetical order. Again, technically it's not wrong if you don't. It's just more proper if you do. In my math lab, some problems it gets picky about it. You have to have them in alphabetical order. Other problems it doesn't matter. So if you put one in there, if you did put this in as like x to the 17th, z to the 5th, y squared, and it counted it as wrong, let me know and I go back in there and I'll edit those. Because there are some that my math lab's kind of picky on that really it doesn't have to be. So I will go back in and change those grades for you if you run into one of those. How about this one? X to the 4th to the power of 3. I'm taking an exponent and I'm raising it to another power, another exponent. You multiply them. Very good. 4 times 3 is x to the 12th. Again, that's because we have x to the 4th here, which is 4 x's multiplied together, times another x to the 4th. It's the power of 3, so there's a third x to the 4th. And if I multiply those all together, I now have a total of 12 x's being multiplied together, or x to the 12th. So I had 4 of them, and I did it 3 times. That makes 12. So y to the 7th to the power of 11 is going to give me y to the 77th. Very good. Again, I can have more than one variable in there. I can have x to the 5th, y to the 12th, z to the power of 4. What's this going to give us? 4 times each one. So x to the 20th, 5 times 4 is 20. Y to the 48. Very good. 12 times 4 is 48. And z to the 4th. Again, think of this as z to the 1. 1 times 4 is 4. Now, when we throw numbers in there, we're going to have to be a little bit careful. And we'll go over this a little bit more as time goes on. So we have 8x squared times 3x to the 5th. Remember, when we multiply, we first combine the counts. A lot of people will look at this and say, oh, we're dealing with exponents. I'm going to add 8 and 3 make 11. What's wrong with that? We're multiplying. So when we combine the counts, the numbers, we still must multiply. 8 times 3 is 24. Then I got x squared times x to the 5th, which is x to the 7th. Now I get this all the time. Why are we adding when it says multiply? Well, we are multiplying. X squared times x to the 5th is x to the 7th. It's just, it appears like we're adding because the powers add together. So let's try 11x to the 6th, y to the 3rd, z to the 5th, times 3 x to the 4th, y to the 5th, z. Where are we going to start? 11 times 3, very good, which is 33. And then x to the, perfect. 6 plus 4 equals 10. So x to the 10. Y to the 8. Good. 3 plus 5 makes 8. And z to 6. Bless you. 5 plus 1 makes 6. So z to the 6. Okay, so we can combine those simple one-digit algebraic numbers with multiplication by combining powers. Well, what happens if we have a single-digit number times a multiple-digit number, like this? This, believe it or not, is no different than having 5 times 21. Because what it's asking me to do here is take 21 times 5, and then I do 5 times 1 is 5, 5 times 2 is 10, so 0 carry the 1. This can be done by exactly the same process. I write the two-digit number first, the longer number on top, the other number on bottom, and I am multiplying. 8 times 3 is 24. It's positive 24. 8 times x is 8x. But there's a shortcut that most of you have probably seen for this. Called distributing. And all distributing is, or distribution is taking this problem and compacting it so that you don't have to rewrite it and do the long multiplication. So rather than writing it out like this, we're just going to do it right in here, where you do 8 times x is 8x, 8 times 3 is 24. You get the same answer. Now to me, this makes a lot more sense because it is just our long multiplication. But you can see how the two processes come out to be the same. I'm going to do a few examples doing them out the long way, and then I'm going to start doing them the short way too. So we might have 3x times 2x minus 5. So again, I'll have the 2x minus 5 will go on top times 3x. Notice, since we're multiplying, I don't have to worry about lining up my place values. If I were adding or subtracting, that 3x would have to be with the 2x, because they have the same name. So now I have 3x times negative 5 is negative 15x. Remember, the symbol in front always goes with the number after it, so that's a negative 5. Then 3x times 2x, 6x squared. Very good. We would have got the same result here. 3x times 2x, 6x squared, and 3x times negative 5, negative 15x. So what if we have 5x to the third times 8x squared minus 2x. Five x to the third times 8x squared. Perfect. 40x to the fifth. 5 times 8 is 40. X to the third times x squared is x to the fifth. 3 plus 2 is 5. 5x to the third times, now remember this is a negative 2x. Negative 10x to the fourth. Good. 5 times negative 2 is negative 10. X to the third times x, that's an invisible 1 there, so 3 plus 1 is 4. X to the fourth. So in your notes, I'm going to have you guys try one. So 7x times 3x plus 9. Give that one a shot quick. So we do 7x times 3x is 21, x to the second, x squared, perfect. 7x times 9, 63x, good job. Now they can get a little more complex than that. We might have 5 times 8x minus 4 plus 31. We have to do order of operations here. Now, in the parentheses, is there anything we can add there? No, there's not. I mean, all the ones we've been doing, technically, we should have been checking to see if we can combine within the parentheses, but we can't. So if we can't do anything inside the parentheses, the next step is to see if there's anything we can do to the parentheses, which is what we've been doing. Multiplying by that number outside the parentheses. So 5 times 8x is 40x. 5 times a negative 4, negative 20. Now we have the plus 31. Can I combine that positive 31 with any parts of what I already have? Got negative 20 and positive 31. So negative 20, positive 31 gives me positive 11. So this is 40x plus 11. We might have something like this. So again, we look at the parentheses. Is there anything to do inside the parentheses? No. So then we have to look, is there anything to do to the parentheses? Yes, being multiplied by 5x. So 5x times 3x? 15x squared, 15x to the second. 5x times negative 7? Negative 35x. And we have the negative 13x squared there. What do we have to do with that? Combine it with the 15x squared. Good. It has to have, combine it with addition or subtraction, have to have the same name, which is the same variable and the same power. So 15 and negative 13 make 2x squared. Now I get asked all the time, why doesn't that become x to the fourth? Because when we add or subtract, we keep the same name. Oh, we might have 18x squared minus 3x times 5x plus 4. So here again, we see the parentheses, and the parentheses should always tell us do something here first. Is there anything to do inside that set of parentheses? No. Now I'm going to point out here just that there are two types of parentheses. There is the parentheses that's an enclosing symbol in our order of operations where we have to do everything inside of it first. And then there is a parentheses like this one that's just a separator. It is separating that 5x plus 4 so that we know that is a single algebraic number. Just like in our negatives, if we were at 5 times negative 3, we'd put the negative 3 inside. It's not telling us we have to do anything inside there first. It's just separating that negative 3 so we know what it is. So now there's nothing to do inside this parentheses. Is there anything to do to the parentheses? Multiplied by? Perfect. It's not 3x, but a negative 3x. So negative 3x times 5x. Negative 15x squared. Negative 3x times 4. Negative 12x. We still have that 18x squared up here that needs to come down. And I can combine the x squareds. 18 and negative 15 make positive 3, and it stays x squared because I am now adding negative 12x. So let's have a little more fun with it. Something like this. Again, we see the parentheses. Is this parentheses telling us to do something inside of it? No. So we have to see if there's anything to do to it, and it is multiplied by negative 3x to the fifth. So negative 3x to the fifth times 2x to the third. It's negative 3 times 2 is 6, and it's x to the 8th. Very good. 5 plus 3 is 8, so x to the 8th. Negative 3x to the 5th times negative 5x. Perfect. Positive 15, x to the 6th. Perfect. Negative 3 times negative 15 is a positive, or negative 5 is a positive 15. X to the 5th times x, we treat that as 1. 5 plus 1 is 6. Now we still have the 7x to the 8th here. Negative 9x to the 6th here. So we can combine 7x to the 8th and a negative 6x to the 8th make 1, or just x to the 8th. 7 minus 6 is 1x to the 8th, or just x to the 8th. 15 x to the 6th minus 9x to the 6th. 6x to the 6th. Very good. So here we can have multiple parentheses in there. We still go left to right. So going left to right, here's our first parentheses. Is there anything to do inside that parentheses? No. How about to that parentheses? Times the 5x. So 5x times 3x is 15x squared, yep, x to the second. 5x times negative 4. Negative 20x. Good. Now we move to the next set of parentheses. Anything to do inside those? No. How about to those? Times the 3x, right? So 3x times 2x is 6x squared goes positive, so I'm going to put plus in front of it. 3x times 7. Again, positive, so I'm going to put plus 21x. Good. Now what? Combine 15x squared and 6x squared is 21x squared. When we add or subtract, we keep the same name. So it stays x squared. And then negative 20x and positive 21x plus 1x or just plus x. I'm going to have you guys try one in your notes. Try that one in your notes quick. See what you come up with. Okay, so as we go left to right, we see the first parentheses. Anything to do inside it? No. So to it is times the 8x. 8x times 3x? 24x squared. 8x times negative 7? Negative 56x. To the next set of parentheses. Again, nothing to do inside it. So times the negative 2x. Negative 24x squared. And negative 2x times negative 9x. Positive 18x squared. I screwed that up. That should be just a 9, not 9x. So if you had that as 18x squared, that would be my mistake, not yours. So that should be just 18x. That's what I get when I don't have my morning coffee. So we can combine 24x squared and negative 24x squared. Just going to cancel out. It's 0. Negative 56 and positive 18. Well, negative 56, positive 18 makes negative 38x. So that's all that comes out to be. Okay, so remember, homework 1 is due today. Did anybody have any questions on that we haven't answered yet? Okay. So then, starting today, quiz 1 should have actually opened up at like 8 o'clock this morning. It must be done by tomorrow, Tuesday, at 11:59 p.m. So you have the rest of the day today and all day tomorrow to get to the quiz. The quiz you get 2 attempts at. But you can't just attempt each problem twice. You have to do the whole quiz and then come back and redo the whole quiz. But after you do the quiz once and submit it, it'll allow you to go back and you can see what questions you have wrong. So that gives you a chance to study and look things over before you redo it. So I would make sure you would at least do the first attempt sometime, early, if not today, early tomorrow, so that you know what you have to figure out before you redo it, so you have time to redo it. There is a 2-hour time limit on the quiz, just so you know. The system makes me set a time limit, so you can't just leave it open and sit there for a day and a half and work on it. So once you open the quiz, there's 2 hours before it has to be done. If for some reason you close the quiz, it will make you use your second attempt to go back into it. If that happens, let me know and I can add an attempt for you if there's a power flicker or something like that happens. Also, if anybody is using like an iPad or anything like that, or doing homework on your iPhone, there tends to be some glitches with my math lab. So occasionally you'll do an assignment and it won't show up as being done if you're using an iPad. So I'm not sure what's happening there, but if that happens to you again, let me know and we'll figure out what's going on. Also then, homework 2 is due for Wednesday. About class time Wednesday. I highly recommend you do the quiz first. The material on that quiz will be similar to the material on homework 1. Any questions? Okay, so I'll give you the last 17 or 18 minutes here if you want to use the computer lab next door to get started, or if you want to go somewhere else to work on it, you guys are free to go.